So let's dive in straight into giving answers to this question. So the first question here gives a list of substances. You're asked to, pick answers to the questions below from this list of substances. So the first one says, which of the substances is a basic oxide? Now, when we talk about basic oxide, we're talking about metal oxides. So oxides of metals, basically. So if you look at the option here, you see that the most suitable answer here is calcium oxide. So calcium oxide is a basic oxide because it's majorly a metal oxide. All right, so we go to the next one. It says, which of them contains carbon atoms only? Of course, it has to be an allotrope of carbon for it to contain just carbon atoms only. So option here is simply graphite. So just write graphite right here as the answer to this. All right, so you see the questions are quite easy for this particular year. Which of the substances above is manufactured by fermentation? So if you look at the options, we have, when you talk about fermentation, it is one of the methods of producing alcohol. So you look at your option, you see it's only ethanol that falls into that category. So you simply write ethanol as the answer right here. Next one is which is produced by decomposition of vegetation. Now, under chemistry of the environment, remember that one of the sources of one of the greenhouse gases, which was methane, is that produced by decomposition of vegetation. So if you look at the options here, you see that methane is in the option. So have methane as the answer right here. Which one contains aluminum oxide? Of course, you know the ore of the aluminum oxide. The name is bauxite. So we have bauxite in the options. So the right bauxite here. All right, which of them causes acid rain? Now, two oxides are likely to cause acid rain. Either we have sulfur oxide, sulfur dioxide, and then the oxides of nitrogen. Now, we do not have oxides of nitrogen in this option, but we have sulfur dioxide. So that is going to be the answer here. Sulfur dioxide. And then which of them is a simple molecule with 11 atoms? Okay, so 11 atoms is quite a number of atoms. So if you look at bauxite, of course, bauxite is Al2O3, so it's definitely not bauxite because there are just 5 atoms here. Calcium oxide is CaO, so it's definitely not this. Ethanol is C2H5OH, so we do not have 11 atoms here. We have 7 plus 1, 8 plus 1 here, 9. Okay, so it's definitely not graphite. It's not methane. We already said the formula of methane is CH4. All right, so when you look at all the options, it's not nitrogen because nitrogen is N2, O2. But these are not 11 atoms. Sulfur dioxide, I already said SO2. No. So we have propane and propane. Remember the general formula of alkanes is CnH2n plus 2, while alkenes is CnH2n. So let's generate for propane. So propane is definitely the third member of that family. So N is 3. So we're going to have, for propane, we're going to have C3, H, so 3 times 2, 6 plus 2, 8, H8. And then for propene, we're going to have C3, H6. So look at this. Which of them has total of 11 atoms? You see that is propane because 8 plus 3, that's 11. So we go back and put propane as the answer to this. Which is produced when limestone thermally decomposes in the blast furnace. Of course, when limestone, that's calcium carbonate, it's thermally decomposed, you have calcium oxide plus carbon dioxide. So we have this in the options, in the list of substances. So we simply pick calcium oxide. All right, so the next question says, which of them is a gas that is approximately 21% of dry air? Okay, so when we look at the composition of dry air, we have nitrogen, it's about 78%, and then we have oxygen, which is 21%. So these are quite easy questions to deal with. It's a monomer in addition polymerization. Now, For it to be a monomer in addition polymerization, it has to be an alkene. Only alkenes can basically undergo addition polymerization according to the syllabus. So we look at our options, we see that propene is the only alkene in that option. All right, so and that gets you very simple or very easy 10 marks. All right, so let's move to the next set of questions. Okay, so we have a table here. Atoms are made of electrons, neutrons, and protons. So we have to fill the table. So you know that electrons have negative charge, so that's -1. You know your protons are positive because they are in the nucleus, so they are positive 1. And then we talk about their masses. Of course, we know the mass of the relative mass of the neutron is 1. This is 1. So that's straightforward enough. Now, next question says atoms of the same element are known as isotopes. So we have two isotopes of potassium here. You can see what makes them isotopes. They have the same number of protons, but different number of neutrons, and that is why their mass numbers are different, or their nuclear numbers are basically different. So different number of neutrons is what results in this. Right. So having that at the back of your mind, then you could solve and complete this table. It's quite easy. All right. Since potassium proton number is 19, so obviously protons is 19. And since it's a neutral atom, meaning it is not charged, the number of protons is equal to the number of electrons. All right. And then how do we get the number of neutrons? So basically, you're going to do neutrons is equal to mass number or the nuclear number minus the proton number. So we have basically 39 minus 19 here. So that's obviously 20. So 20 is the answer here. All right, so we go to the next one there. This is different from this. This is charged this time. So this is more of a cation, while this was a neutral atom. So in this case, number of protons stays the same to be 19, but the number of electrons is going to change because it's obvious that this charged, for the fact that it is charged, means it has giving out an electron. So for us to do this, it becomes the number of protons minus the charge on it. Since it is positive, it means it has donated. So since it has donated, we have to subtract. So how many of it do we have? We have just one of it. So it becomes 19 minus 1. And number of electrons is 18. That is how to do that. And then to get the number of neutrons, it stays just like the first one. Do the mass number, that's 41 minus 19. Okay, and then we have, when you complete this, you should have 20. Okay, so we go to this question now. You can see this question is for 2 marks. So we have to find the relative atomic mass. So to look for the relative atomic mass, of course, you know the formula, which is that, let's represent as RAM now. RAM is equal to the percentage abundance. Okay, so we have 90 times the mass, 89, plus we have the percentage of the second isotope, which is 10 times 41. Everything should be divided by 100. Okay, so this is what is expected when you have a question like this. So moving forward, if you compute this, you're going to have the numerator is going to give you 39,3920, and then you divide that by 100. So when you're solving this question, there is a mark for this. Okay, there is 1 mark for doing this. So that's why you have to follow this step so you could get all of the mark. However, okay, when you divide this, we have 39.2. That is how to solve the question on relative abundance. Okay, just make sure you show the steps that you took to get the answer, and of course, it says it has to be in 1 decimal place. So this is the result in 1 decimal place. So they are quite easy questions. All right, so go to the next one. An isotope of aluminium has a nuclear number of 27. Aluminium has a relative atomic mass of 27. What are the conclusions that can be made? Now, we're told that the isotope of aluminium has a nuclear number of 27. That aluminium itself has a relative atomic mass of 27. The same number of mass number and the same nuclear number or the same relative atomic mass simply means that there is only one isotope of aluminium. That is the conclusion that can be drawn, because the relative atomic mass is equivalent to the nuclear number of the isotope itself. So it means that aluminium has just one isotope. As okay, so we go to the next question. But next question from here is this: a calcium 18 plus 2, that's 20. So for us to give the formula that has the same electronic configuration as this charged ion. So in this charged ion, the electronic configuration is going to be, since it is 20, so the number of electrons in this atom is 18. Since the number of electrons is 18 because it is 20 that's given out, that's donated 2 electrons, so 20 minus 2, that's equivalent to 18. So since we have 18 as number of electrons, the electronic configuration becomes 2 for the first shell, 8 next shell, and 8 for the next shell. So that's 16 plus 2 is 18. So this is what the new electronic configuration of this ion is. All right, so we have to look for an element that has this same number of electrons, which is, it has to be a neutral atom. So if you check your periodic table, you see that argon is the element with 18 number of protons or electrons, basically, because that should be something neutral. That is why it's an atom. All right, so we go to the next one. That should be a negative ion. So which negative ion would have 18 or 18 number of electrons? So for us to have 18 number of electrons, we have several options. You could use sulfur. Sulfur is 16. So sulfur 2 minus. So we could have S2 minus as your answer here, because it would eventually give you 18 since it is 16. Receiving 2 electrons makes it 16 plus 2. That's 18. So you could have sulfur 2 minus. Or you could also have chlorine, the chloride ion, which is this, because chlorine is 17. So the fact that it is gaining 1 electron equivalents it to 18. So these are the options you could have. You could have several others also, depending on which of the answers you want to pick. So either of these is good to go with this particular question. All right, so next question, question 3 says the question is about copper and compounds of copper. Describe the bonding in metallic elements such as copper. Now, one thing you could do here is to always remember the diagram of a metallic element. Okay, the particle model of a metallic element is something like this. We have something like this. All right, we have positive, 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 positive. So this is what particle model of a metallic element looks like. And now surrounding it, we have electrons. So we can just represent these smaller circles with our electrons, right? So we have electrons all roaming around. And then these electrons are equally held in place. They are not falling off due to the electrostatic force of attraction. So since it's a 3-marker question, if you want to describe the bonding metallic, you have to start with looking at this diagram now. You could use this diagram to describe the bonding in the metallic element. So first, we start with it has a regular pattern. Has a regular pattern of positive ions. Or sometimes you want to use a regular pattern, you can say it has a lattice. So lattice could also be used as a word here. So it has a lattice of positive ions. Now, positive ions means all of these circles with positive charge in them. Those are cations, basically. It has a regular pattern of positive ions. Now, these positive ions are what? Are surrounded by delocalized electrons. So surrounded by delocalized electrons. Remember, these delocalized electrons is what enables a metal to conduct electricity. Right? So these electrons are moving. That's many of the localized electrons. They are all roaming around this the lattice of positive ions. So we could say it has a regular pattern of positive ions surrounded by delocalized electrons. Okay, so full stop. Now we could also add that these delocalized electrons, sorry, erase this. Let's pluralize it. These delocalized electrons are held together by electrostatic force of attraction between electrostatic force of attraction between the positive ions and the negative, of course, the negative electrons. So you see, and the electrons, basically. These electrons we know are negative. So this is how to get the mark. So the first mark here goes to the fact that you mentioned that it's a regular pattern of positive ions. So one mark here. Now, the second mark says they are surrounded by delocalized electrons. This is where you get your second mark. And then the third mark is where you emphasize that these localized electrons are not falling off because they are held together by electrostatic force of attraction between the positive ions and the electrons. That is the delocalized electrons, basically. So this is how to describe a metallic bond. So you observe that just by using the diagram, you are able to get ideas on how to describe a metallic bond. So I always advise students to know the diagram. From the diagram, you can simply pick out the description. Explain how solid copper conducts electricity. Of course, you know that they conduct electricity due to mobile electrons. Now, do not make the mistake of saying that they conduct electricity due to mobile ions. That's wrong because there are no ions here, okay? They are electrons. The electrons are mobile. That is why they conduct electricity. So metals do not conduct electricity because their ions are mobile. They do not have ions here. What they have are electrons. Okay, they conduct because of their mobile electrons, while your ionic compounds in their molten and aqueous state would conduct due to mobile ions. You could use that, but for metals, it is mobile electrons. Because examiners will always complain that students make a mistake of using ions instead of electrons. So you have to be careful about that.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have you know, the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E-levels as well, and also for the Edexcel. So we have for the Cambridge E-levels and Edexcel E-levels, okay? And we have also across the subject mathematics, which is usually the hot cake when it comes to E-level. mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for A-level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com and they'll reply to you.
Copper is in alloys such as brass. States one reason why alloys are more useful than pure metals. Of course, you know that alloys are harder. They are harder than pure metals, making them more durable. So they are harder than the pure metals. So making them durable, okay, making them durable. All right. Or you could say they are stronger, either of them. Name the substance that is present in brass other than copper. Of course, you know that when we talk about brass, we look at copper and zinc. So zinc is the other element that makes up brass. All right, so go next questions. Copper 2 sulfate crystals are made by the reaction between copper 2 carbonate and dilute sulfuric acid using the following steps. So the sulfuric acid has a concentration of 0.100 mole per dm cube. All right, so from this information, we have various steps where first the powdered copper 2 carbonate is mixed and all of this information. Now, let's go to the questions. Give two observations in step one. All right, so step one is where the powdered copper 2 carbonate is added to dilute sulfuric acid to make sure it's stirred. Now, if you look at this reaction, so let's see, we have copper 2 carbonate, which is CuCO3. You added sulfuric acid to H2SO4. So you're going to have, of course, you're going to have copper 2 sulfate, so CuSO4 plus, you're going to have water formed here. Since it's a reaction of a metal carbonate, you're also going to have carbon dioxide being produced. That's a gas. All right, so this is what the equation of the reaction looks like. Also, right here, copper 2 sulfate, the color is blue. So it's always, you are going to have a blue color. Now, since there is a gas produced, you're also going to have you're going to have bubbles or effervescence in the reaction. So that should guide you to the answer to the two observations in step one. So step one, you're adding the copper 2 carbonate to, you added dilute sulfuric acid to the copper 2 carbonate. So, and you stirred it. So what you observe is, number one, you're going to have bubbles. You're going to have to observe bubbles, observe. You're going to see bubbles, or you could say you observe effervescence. Okay, so bubbles will be observed. Another thing you're going to observe is, since you're forming copper sulfate, blue solution formed. You're going to have a blue solution that is formed, and that is copper 2 sulfate. So these are the observations you could have. Another observation could also be that the solid will dissolve. Okay, the solid dissolves. Okay, so that could also be the third observation you could use there. State why the reaction stops in step two. Okay, so let's go to step two and read what happens in step two. More copper 2 carbonate is added with stirring until the reaction stops. So remember that you're adding copper 2 carbonate to sulfuric acid. So the reaction will stop because all of the acid has been used up. All of the sulfuric acid has reacted, basically. All the sulfuric acid has reacted. Remember that the sulfuric acid is the agent dissolving the copper 2 carbonate. So when it's no longer, when the reaction has stopped, it simply means that you have used up all of the sulfuric acid. All right. Okay, so the next one says name the residue in step three. So let's go to step three. Unreacted copper 2 carbonate is separated from aqueous copper 2 sulfate by filtration. So in the residue, you're going to have your, of course, you're going to have your copper 2 carbonate as your residue, while your filtrate is going to be the copper 2 sulfate. So we go and we have that the residue is going to be copper 2 carbonate. All right. Name a substance other than copper 2 carbonates that can be added to dilute sulfuric acid to produce aqueous copper 2 sulfate. So it has to be, since we are reacting with an acid, you could pick an oxide of copper, or you can pick an hydroxide of copper, since it's an acid-base reaction, basically. So Instead of using copper 2 carbonate, you could use copper 2 oxide, since copper 2 oxide is also a basic compound. Okay, so you can use copper 2 oxide in this case, or you can also use copper 2 hydroxide, just something basic so that we could form the salt as expected. The solution at the end of step 4 contains the maximum amount of copper 2 sulfate that will dissolve at that temperature. State the term used to describe this type of solution. So a solution that has the maximum amount of substance that can dissolve at that temperature, we refer to such solutions as saturated. It is saturated solution. Saturated solution. All right. So step 1 is repeated using sulfuric acid of concentration. So basically, we are increasing the temperature, the concentration rather. So instead of using 0.1 now, the concentration has been increased to 0.2. All other conditions are the same. The rate of reaction increases. You have to explain why the rate of reaction increases. Give your answer in terms of particles. Now, in this case, we have increased the concentration, and then your answer should be in relation to what happens when you increase the concentration, especially when it has to do with particles. So remember that when you increase the concentration, there is an increase. There is an increase in the particles per unit volume. There is an increase in the particles per unit volume, resulting in increase in the frequency of collision. So when you're talking about a particle, using the particles to represent, to explain effect of any of these factors on rate of reaction, you have to look at the frequency of collision as well. It's very important. It's very important to use the frequency of collision to talk about the effect of increasing the rate of effect of changing the factor of any rate of reaction. So we've said that when you increase the concentration, what happens is that you've introduced more particles. Therefore, there's an increase in particles per unit volume, which results in the increase of the frequency of collision of the particles. So the particles will collide more frequently because you have increased the concentration. Copper 2 sulfate crystals have the formula this. State the term used to describe the substance that is chemically combined with water. Of course, we know this is hydrated. This term, when you see something is hydrated, it is chemically a substance that is chemically bonded with water. Okay, and that gets you the 15 marks for that question. You can see these questions are quite easy. Okay, so go to question 4. The question is about nitrogen and its compounds. We have the atomic here, the atomic nature. You have to complete the dot and cross diagram. Okay, so if you look at the periodic table, you see that nitrogen is 7, proton number 7. So configuration is 2 and 5. So let's play around with this first, right? So we should have 5 valence electrons. So let's play around with 5. I'm going to use 5 electrons. So let's distribute it. Let's see what's going to happen. So 1 here, 2 here, 3 here, 4 here, and 5. Let me use a different marker here, just show you something. So that's for the first nitrogen. So let's do it for the second nitrogen. Let's use a different one now. So we have 1, 2, 3, 4, and 5. Now, this is what your basic knowledge would simply ask you to do. However, this is not correct. Now, why is it wrong? It is wrong because when we paired, for the compound to be stable or for the molecule to be stable, all of the electrons, unpaired electrons, need to be paired. Right? So that is why this particular model is wrong. So what we need to do now is all of the electrons that are left unpaired, we move them into the intersection so that they pair themselves up there. All right, so see what I'm going to do now. So I'm just going to erase this now. So look at what I'm going to do. So I'm going to pick this one. So I'm going to erase this one because this is going to move to this. So this is being removed now. I'm going to move it into the center. You understand what needs to be done in questions like this. So move it to the center now. So I've moved it to the center. So this is it here. Okay. I've moved it to the center. Okay, let's do it this way. Let's have the usual thing that was at the center before. Sorry about that. Let's have what was at the center in the first instance. So let's keep that also there. Let me put what was at the center before. Okay, so this was what was at the center. So I'll just move it up a bit. This was at the center at our first diagram. So, all right, so this was at the center in our first diagram. So what I'm going to do now is I'm going to move these unpaired ones now into that center so that they can be stable. We want to form something stable. So I'll start with eliminating this one. So I'm going to remove this particular one now and move it to the center. So let's do that together. So I will erase it first. I'm going to move it to this intersection. So move it in here. So it's right here now. So I've moved it in there. So the same thing applies. This one now, I'll also move it into that center to pair up what was there. So I will erase this now and then bring it to the center of the whole thing so that it's paired up. See that? Okay. So we have these other two also remain. So I'm going to erase them and move them to the center of the whole where the whole event is occurring. So I'll move this away from here. And also move this away from here. So I'll all move them to the center of that. So have this, and then we have the blue one, which is this. Yeah, so this is what it's supposed to look like. So when you look at this now, when we want to write nitrogen, it's always a triple bond because there are three pairs of paired electrons. So it's going to be something like this. So this is how you should do a question like this. I always advise students to draw the way they distribute it first to see how many electrons are left unpaired before you now start doing what I just did. So to give you a clearer picture of how the bonding is supposed to be. All right, so moving forward to the next question. So we have ammonia is manufactured. So just have to switch this up. Ammonia is manufactured by reacting nitrogen with hydrogen. All right, so we have to give the typical conditions for EBA process. Okay, this is always, I call it a traditional question. It's always coming out, right? So first we'll begin that the temperature. So temperature is equivalent to, that is, you can't go into the IGCSE chemistry exam without memorizing the conditions for the EBA process and the contact process. They are always coming out, all right? So this is the temperature. So the pressure now, the pressure can be expressed in either you see in kPa or you leave it in ATM. So either way, 200 ATM. So just divide the kPa value by 100 and you get the answer in ATM. Okay, so that is for that. Remember, every of your conditions should have units. And then we have catalyst. Catalyst is ion. Ion is the catalyst. All right, and that gets you the mark for this. All right, so these are the conditions for the EBA process. Write the simple equation for the chemical reaction in the EBA process. Of course, you know it's nitrogen plus hydrogen. Now you need to be careful here. It has to be a reversible arrow. Okay, do not use a one-directional arrow here. It's a reversible arrow, and then you have ammonia. Right? So just one mark. So just balance it by putting 2 here, and then you put a 3 here. So this is the equation for the production of ammonia. All right, so we have to balance this equation. Ammonia is converted into nitric acid, two-step process. So balancing of chemical equations. So if you look at this equation here, you see that there are 4 nitrogens on this other end. So since there are 4 nitrogens on the other end, what we need to do is simply to put 4 nitrogens here, right? 4 nitrogens there, okay? So Then we look at hydrogen. Hydrogen is 12. There are 12 hydrogens on the left. So to make it hydrogen balance, we put a 6 here so that there are 12 hydrogens here. So 6 times 2, 12. Then oxygen, 4 plus 6, 10 here. So just put a 5 here. That balances that equation. Give the oxidation number of nitrogen in this. So let's calculate that. So we know hydrogen oxidation number is always 1. So N is unknown plus hydrogen is plus 1. So 3 into bracket plus 1. Everything should be equal to 0 because it's a neutral compound. We're going to have N plus 3 equals to 0. N equals to minus 3. So the oxidation number of nitrogen here is minus 3. For the second compound there, oxygen is in group 6. So the oxidation number of group 6 is minus 2. So it becomes N plus into bracket minus 2. Everything should be equal to 0. So N minus 2 equals to 0. So N will be equivalent to plus 2. So basically, just know that, just know the groups the element belongs to and the oxidation numbers. I think we've done that in a couple of videos we have done. So you can watch these videos again where we said group 1 is plus 1, group 2 plus 2, group 3 plus 3, and on like that. When you know that, you have these questions very easy to do. Okay, so define oxidation in terms of oxidation number. Of course, oxidation in terms of oxidation number. So oxidation is increase in oxidation number. Oxidation is increase in oxidation number. This is how to define oxidation in terms of oxidation number. And in terms of reduction, if you're looking at it in reduction in terms of oxidation number, that's the opposite. So decrease in oxidation number. So in step 2, oxygen and water react with the nitrogen, oxide of nitrogen to produce nitric acid as the only product. So let's write the equation for that. So oxygen is O2 plus water, H2O, plus NO. And then there's just a single product, which is HNO3. So this is what we expect to do. So let's balance this up. We look at this now. So we have how many hydrogens? We have basically 2 hydrogens on the left. So let's say that let's say we have 2 here. Let's assume we have 2 here. So we look at, we are going to balance oxygen last. So 2 nitrogens. So we have 2 hydrogens, 2 nitrogens, for example. So let's calculate oxygen now. So there are 6 oxygens on the right. So we check how many oxygens on the left. We have 2 plus 1, that's 3 plus this 2, 3 plus 2, that's 5. So what do we do? What do we do to balance it to make it 6? So let's say we put a 2 here as well. Okay, let's say we put a 2 there. So hydrogen now is 4 instead of 2. So on the right it becomes 4. So we have 4 hydrogens on the left and we have 4 hydrogens on the right. Okay, we're moving forward now. So how many oxygens? Okay, before we come to oxygen, let's talk about nitrogen. So nitrogen is now 4 too. So we change it. You can see the gradual process of balancing. It takes a while, but you have to learn how to balance it gradually. It's not just to put the numbers there. So 4 nitrogens, 4 nitrogens. Good. Now let's check oxygen. Is it okay now? So we have 12 oxygens on the right. We have 4 here plus 2 here. That's 6. So to make it 12, we just put a 3 here. Okay, and that balances that equation. So you can see the gradual way how to balance it. It will take a while, but you will get it. That is how you balance.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajiroTech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the EdXL. So we have for the Cambridge E levels and EdXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they will reply to you.
Okay, so we have a question on stoichiometry. We have that ammonia is converted into ammonium salt action. Then we are told that 360 dm cube of ammonia gas, that's the volume of ammonia gas. So this is the volume of the ammonia gas measured at RTP react with excess sulfuric acid. So calculate the mass of ammonium sulfate produced using the following steps. So first we have to find the number of moles of the gas in 360 dm cube. We're told that the 1 mole of any gas is this. So this is a question that involves gases. So if you check your stoichiometry formula, which you should already have at the back of your mind, remember that when there is a question that involves gases, the number of moles is volume over 24 dm cube. Right? That's the formula that applies in this case. So we have the volume to be 360. We have already given this 24. So we'll just do N equals to what? 360 over 24. So I'll use my calculator now. 360 divided by 24. So I have 15 as my answer, as the 15 moles here. So the basic thing here is just know the formulas. When there's a gas, you know what to apply. I've done a video on stoichiometry on YouTube, so just check it. This channel, you see where I give all the formulas you need to solve stoichiometry based on the states. Is it a gas? Is it a solution? Is it a solid? Is it particles, molecules, or ions? They are formulas that you just pick and use. All right, so the next one says calculate number of moles of the ammonium sulfate. All right. Now, what information do we have about ammonium sulfate? We basically do not have so much apart from the equation of the reaction. So what we can do is to do mole ratio comparison. So let's do a mole ratio comparison. So we have a known and we have an unknown. So what's the known? The known is ammonia, and the unknown is the ammonium sulfate. So we don't know this. Sorry, so this is SO4. So what's their ratio? Let's go back to the equation. What's the ratio they share? So it's 2:1. You can see the equation. 2 is the coefficient of ammonia here, and then 1 is the coefficient of the ammonium sulfate in the balanced equation. So we just have 2:1. Now, we just calculated the number of moles of ammonia to be 15. So 15 ratio, this is unknown. So 15 ratio X. So we continue to solve. We cross multiply here, it becomes 2. So cross multiplication, we have 2x equals to 15. So we simply divide by 2, divide by 2. So X is equivalent to, so 15 divided by 2, that'll give you 7.5 moles. That's how to go about that. You use a known to get the unknown. Oh, that's good. Now, the next part of it now says calculate the mass if the MR is this. So remember, what formula relates number of moles to MR and mass? So remember the formula, that number of moles is mass over MR. So we're looking for M. So M will be equivalent to N times MR. So we have N already to be 7.5 multiplied by the MR is given to be 132. So let me compute that. So 132, so 132 times 7.5. All right, so what I have here is 990. So 990 is our answer, right? So that gets you the answer to that. So 15 marks up for grabs. All right, you can watch this video over and over again to see what was done. If it's not clear, you just do it over and over again, and then watch other videos I've done on solving past papers. I did for 2024, there's 2023. You could watch those ones as well to get clear understanding. So methanol is manufactured by the reaction. Okay, we have this reaction. Here's what happens to the concentration of the methanol when the reaction is at equilibrium. Explain your answer in terms of rate of forward and reverse reaction. Now, this is a two-marker question. Basically, what this question is saying is define equilibrium. That's just it. Okay. So remember, when we have to define equilibrium, there are two definitions that you have to use to get 2 marks. Number one is that the rate of the forward reaction, the rate of the forward reaction is equal to the rate. The rate of the forward reaction is equal to the rate of the backward reaction. So that is the first one you should adopt. All right, and then the next one is, that means we have answered this part that says, explain in terms of rate of forward and reaction. Now, the next one is talk about it in terms of concentration now. That's why the other one says. And remember, the second definition of equilibrium in terms of concentration is that the concentration is no longer changing. They are not equal, remember. Don't use the word they are equal. They are no longer changing, meaning that the concentration is constant. It's not changing any longer. If they are not equal, they are just constant. Not necessarily equal. They are just constant, not changing any longer. So this is what you're expected to do. So basically, the question is simply telling you define equilibrium. And that's a common question over the years. All right, so the reaction is carried out at the pressure of 75 atmosphere and the temperature of this. Here are two disadvantages of using a pressure below 75 atmosphere. Now, based on Le Chatelier's principle, when we talk about pressure, pressure is dependent on the number of gaseous moles in the reactants and product. So let's calculate the number of gaseous moles in the reactants here. So it's simply 2 here plus 1 here. You're looking at the coefficients. So that's total of 3 gaseous moles are involved here. Remember, it has to be gases. When you talk about pressure, you're aiming at the gases. So if you don't have a gas in the reactant, you ignore it. You only focus on the gases. Right? And for the products, there's just one coefficient, so one mole here. So the rule is that, according to Le Chatelier, when you increase the pressure, it favors the side with lesser moles. So increase in pressure would produce more yield of this. That is what it means. Increase in pressure would favor the side with lesser gaseous moles. But in this case, in this question, we are not talking about increasing pressure. We're talking about decreasing the pressure. So when you decrease the pressure, it will favor the side with more gaseous moles. That is, it will move the equilibrium to the left because the left has more gaseous moles. Now, what does that mean? It means that when the equilibrium is shifting to the left, you are producing more reactant, meaning there is less yield of methanol because the equilibrium has shifted to the left. So one of the effects of doing that is that we'll go and write is that there will be less yield of methanol decreases because equilibrium shifts to the left. That is in terms of equilibrium. Now, also in terms of rate of reaction, when you drop the pressure, what happens? The rate decreases. So rate of reaction decreases. So we talk about it in terms of equilibrium, and then we talk about it in terms of rate of reaction. And that solves that question. All right, so effects of catalyst. When you add catalyst to a reaction at equilibrium, of course, you know that there is no change, no effect in this case. And then if you add a catalyst on the rate of reverse reaction, of course, you know that a catalyst increases the rate of reaction. So increases here. These questions are quite very easy. Okay. If a temperature of more than 250 degrees Celsius is used, the yield of methanol decreases. What can be deduced about the forward reaction? Now, when the temperature is raised, we observe that the yield of methanol decreases. That tells you that the forward reaction is exothermic in nature. Remember when Le Chatelain was discussing the effect of temperature on the equilibrium position, he says when you increase the temperature of the rate of the forward reaction of an exothermic reaction, equilibrium shifts to the left. So if you want to produce more yield, it has to be in an endothermic reaction. Basically, you have to increase the temperature. If you want to produce more yield in an exothermic reaction, you need to drop the temperature. So this is simply an extract of application of Le Chatelier's principle. All right. So when we talk about temperature, we look at is the reaction exothermic or is the forward reaction exothermic or is the forward reaction endothermic? But when we look at pressure, we look at number of gaseous moles of the reactant and product. So just which of the elements from the list is a suitable catalyst for the reaction? So the suitable catalyst has to be copper, and the reason is because it's a transition element. So transition elements are suitable catalysts, like we learned from the periodic table. The transition elements. So transition elements are the most suitable elements to be used as catalysts. All right. Methanol is a member of a homologous series of alcohol. State two characteristics of all members of homologous series. Of course, you know this. This is always a common question. So, of course, I expect you to say that they would have the same general formula, or you could talk about functional groups. So they have same functional group. And there are many others you could also pick out from. So this is a question I believe every student should have gotten used to. So the molecular formula of an alcohol that contains 5 carbon atoms. So first we go to the general formula of alcohols, which is CN, H2N, plus 1 OH. All right, so 5, N is 5, so C5, H, 5 times 2, that's 10, plus 1, that's 11, OH. So this is what the formula looks like. But remember what the molecular formula is all about. Molecular formula is talking about the actual number of atoms are involved there. So let's calculate how many carbons there. We have 5 carbons of automatically 5. So how many hydrogens do we have? So we have 11 plus 1 there, that's 12 hydrogens. And then how many oxygens? Just 1. So this is how to get the molecular formula. Just calculate the actual number of atoms. Carboxylic acids react with alcohol to form esters. Draw the split formula of an ester, which contains 3 carbon atoms. So 3 carbon atoms, it could come in different variations. All right. Remember, the esters are a combination of alcohols and carboxylic acid. So I could vary it. All right. I could give the alcohol 2 carbons and I could give the carboxylic acid 1. Or I could reverse it by giving the alcohol 2 and give the alcohol 1 and give the carboxylic acid 2. So it all depends on how you want to do it. So I'll just pick one variation. You could draw several variations. And if there are questions on this, you could simply drop it on the chat. I'll respond to it. So I'll just draw one variation so this video doesn't become too lengthy. All right, so one variation of this is, remember that I'm supposed to draw, I could just pick out something like this. All right, so remember that at the middle of the whole thing, there should be this, the ester functional group. I've drawn this is the functional group that represents an ester. So I already have 2 carbons already, so I need just 1 more. So I can put the 1 more right here to balance the routine up. So let me add the hydrogens, H here, H here, H here. There should be no H. So this is the ester formation. So this is an example of an ester with 3 carbon atoms. Okay, I could reverse it by putting this as the starting point and these 2 going to the end. So it all depends on either it's 2 to 1 or 1 to 2 gets you the same answer. So this is an example of an ester with 3 carbon atoms. This group at the middle here tells you that it is an ester, right? So that is that. All right, so we move to the next question. Ethyl ethanol is an ester. Name the alcohol. Now, when you're naming the alcohol that forms the ester, we already said that the name, the first name, this first name of an ester is the alcohol contribution. This is the OH contribution, and then the other name is the carboxylic acid contribution. So for it to the alcohol, since it is butyl, it could be butan 1 or, of course, it could be butan 1 or butanol, you might want to call it. And then the carboxylic acid, since it's et, so it's going to be ethanoic acid. Ethanoic acid. So that's easy. All right. So we have a question on empirical formula. So of course you know how to do this. So CH and then there is O. So this is 64.87. This is 13.51. This is 21.62. The first step is to get the mole, number of moles. So divide this by 12, divide this by 1, divide this by 16. Okay, so that's the first step. So by the time you do that division, I just think I need to use my calculator here. Sorry. So we're going to have 64.87 divided by 12. So I have 5.4 here. Let's say 5.4, let's say 5.41. This is 13.51. And then we do 21.62 divided by 16. I have 1.35. So after that division, the next step is to divide by the lowest number here. So the lowest number is 1.35. So 1.35, 1.35, 1.35. All right, so let's compute again. So we have 5.41 divided by 1.35. I have 4 here, 0, I have 4.00 here. So I'll move to the next one, 13.51 divided by 1.35. I have 10.0 here, and then I have 1 here. So now we have the formula. So it's simply C4H10O. So it's straightforward enough. So that is how to solve that question, basically. All right, I think we should be concluding the paper now. All right, I have question 6. This question is about periodic table. Okay, so state the name given to group 7 elements. Of course, you know they are called halogens. We call them the halogens, and we call them halogens because they are salt formers. State which group 7 element is the most reactive. Of course, you know fluorine is the most reactive group 7 element. The physical state and color of iodine. Iodine is solid at room temperature and then it has this gray-black color. Right? Gray-black color. All right, now we have this. Write an ionic equation for this reaction. It's a displacement reaction of the halogens, basically. So ionic equation is we're going to start with the bromine in the neutral, so Br2 plus bromine has a business with the I, not the K. So it's going to be displacing the I. So it's going to be 2I minus. Okay. So it's now forming your 2Br minus. So we are simply ignoring the potassium out of the whole thing plus I2. So that's just it because the bromine has a business with the other halogen, not the potassium there. So we are not concerned with potassium. We're only concerned with the halogens to make it an ionic equation. So this is it. I didn't do anything special. I just followed the pattern on the main equation. All right. So next question here is on bond breaking. All right. So we have this question here. Calculate the total amount of energy required to break the bonds in 1 mole of I2 and 1 mole of Br2. So let's go to the general equation. We have this data already. So I2 and Br2, we are breaking just 1 mole each of them. So this is 150 here, and this is 193 at the other end. So what we just simply do is to add them up. So if you add, so we're going to have for energy to break now. So let's say EB is going to be for I is let's check data again. So it's simply 150 plus 193, right? Yeah. So let's add them up. What do we have? 150 plus 193, 150 plus 3, 150 plus 193. So I have 343. So 343 kilojoule per mole. Course here. So calculate the total amount of energy released when bonds in 2 mole of IBR are formed. So we go back to the table. 175 is for 1 mole. So since it's 2 moles of it, so it's going to be 2 times 175. So EF, I'll call it the forming now, 2 times 175 I think that should give us 350 here. So to get the change in enthalpy, energy to break minus energy you used in forming. So it's going to be 343 minus 350. So I'm going to have a negative answer because it says include a sign. So if you do this, you're going to have minus 7. And that gets you the answer to that. It's quite easy. Okay, straightforward enough. Okay, 2 observations when sodium is added to water. Of course, you know that when sodium is one of the reactions of metals with water, and the reactivity of the group 1 increases as we go down the group. So sodium, when it's reacting with water, of course, you're going to have bubbles. So bubbles will be there to produce, of course, those bubbles will produce hydrogen gas. Okay, and then also you're going to have that you could say that the sodium will melt. Okay, sodium melts. Sodium melts. Let's write it well. So you could say sodium melts, or you could say sodium floats. We're going to have sodium floating at the top of the water. So we could say sodium melts. Sodium melts. All right, so these are the observations you should have. And then finally, thermophthalate is added to the solution when the reaction has finished. So the final color of thermophthalate in the solution. Now remember that when sodium is added to water, we're going to have sodium hydroxide and hydrogen gas produced. So sodium hydroxide is a basic solution. So when you add thermophthalate to basic or alkaline solution, you're supposed to have a blue color. All right, you're supposed to have a blue color. So that brings us to the end of solving this paper. I hope you were able to learn some concepts, and I must say the paper questions were quite easy. So watch out for other papers. We'll also be doing for the practical, that's the alternatives to practical, and the multiple choice as well. All right, so thank you very much for following this channel. All the best.